So yes, you'll need calculator, flowchart, and your notes. Okay. Oh. Hello everybody at home. What? What's wrong? White shirt. All right. So, yesterday, we started our discussion on moles where we estimated the number of atoms in the moles, okay? In today's portion, we're going to be utilizing that flow chart pretty much, what's the word I'm thinking of? Solely? Does that sound right? We're only really going to be using flow chart. How about that? Okay. So let's look at a practice problem. And I'm going to do the practice problems kind of on the big screen myself, just because some of these questions I prefer to walk through them in my own manner. Okay. So here we have screen needs to be on, right? We'll get there. Anyway, while the screen is warming up, we are asked to calculate the number of hydrogen atoms in a compound. Okay? Are you on sample exercise 3.8 as well? Okay. So we're up here at the top. All right. So we have 0.350 mole of C6H12O6. Okay. Now, first of all, do we have an entire mole of C6H12O6? No. So what that's going to boil down to is amounts that are going to be obviously less than a mole's worth. So it's not going to be a complete Avogadro's number worth, okay? So when you do this type of setup for calculating moles, because here in this, we're going to go from moles to atoms, okay? So on the flow chart, where are we going to start? In the middle, okay? In which direction are we going to go? Are we going to go right or left? We're going to go right under the formula units heading, because that formula units or whatever it is, it's a generic stand-in for molecules, for atoms, for whatever. Okay, so I'm going to go here. Okay, so again we had 0.350 mole C6H12O6. I'm just writing this down, okay? And we're trying to find the number of hydrogen atoms, correct? Okay, so just like in dimensional analysis, see if I can't zoom in here a little bit. Just like in dimensional analysis, what is the first thing that we write down? Exactly, the stuff that we already know or what we're given. Okay, and really the only thing we're given is that we have 0.350 mole of C6H12O6. Okay, I'm gonna try to move that in here. And so, in order to get, the number of atoms, what's our method of doing it? What's in that arrow that's between the moles and the formula units? What do we have to use? Avogadro's number, okay? And so we need to cancel out the mole here, okay? And so in Avogadro's number, we have 6.02 times 10 to the 23rd, okay? And we have C6H12O6, okay? And that would be 1 mole. So if we had 1 mole, we would have this, okay? But again, we've only got this, so that's going to come into play. Okay, so that allows for moles to cancel out, okay? Now, in this step, do we have, after we cross everything out, do we have molecules or do we have atoms right off the bat? What's it written right here? We've got molecules. So how do we get to atoms? How do we get to atoms? Here's how. Okay. First of all, how many atoms of hydrogen are in 1 molecule of C6H12O6? 12. It's in the formula. Okay. Times 12 H atoms. And there are 12 hydrogen atoms in 1 molecule of C6H12O6. And I need a... You're going to see me running into this issue is not being able to have enough room to write this. Okay. And this is my fault. I forgot to include the label of molecules there. Okay, my apologies. So that should probably make a little more sense now that we can cross out those molecule labels. And what is our final label here? Atoms, very good. In fact, it's going to be hydrogen atoms. Okay? So, check this in your calculator. Okay, and we're going to walk you through doing this. Careful. Now, since we are dealing with scientific notation, I'm not certain if I mentioned this earlier in the year, but when you're putting this in your calculator, make sure that you are using parentheses. So I got to use somebody else's calculator because mine ran out of batteries. So, okay, follow along here. So, can you see that? Probably not. Let me zoom in. So you have your 0.35, okay, 0, if you want to put the 0 in there, times, because we're going to go across and start multiplying here, parentheses, okay, can you see that at all? Parentheses, 6.02 times 10, and whatever, use caret or whatever, okay? And then I recommend you hit enter right off the bat. You may be the person who likes to do them all at once. That's fine if you're comfortable that way. But I just know that a lot of times that can cause some miscalculations at some point throughout. Okay? So we've got 2.107 times 10 to the 23. So now we have to take that number and multiply it by 12 atoms. Okay? Times 12. And so what do we get for an answer?
2.5284 times
10 to the 24th? Okay, excellent. Now, I'm going to revise this answer, okay? Only for one reason. Sig figs, okay? And it's going to be a simple sig fig fix. Try saying that 3 times fast, okay? Refer back to your given number. Your given number, okay? How many sig figs does this number have? It's going to be a nice review for you. 3. Now this 0 ends up counting. Okay, so you base your final answer in terms of rounding off of the number of sig figs in your given value. So this would actually end up becoming 2.53 times 10 to the 24th H atoms. And that would be your answer. Let's do another practice one with this. I need to put this on it. Maybe this will work. Put it up a little higher. Okay, going back to no. Okay, so we have this practice exercise down here. So we've got a couple questions here. How many oxygen atoms are in 0.25 mole of calcium nitrate? And part B is how many moles of oxygen, or sorry, how many oxygen atoms are in 1.50 mole of sodium carbonate? You notice how in the second one, it doesn't give us the formula. We've got to figure it out ourselves. But let's concentrate on A, okay? So I'm just going to write up top here just so I can not go back and forth. 0.25 mole calcium nitrate. Okay. All right, so I've got 0.25 mole of calcium nitrate, and that's going to be my given. 0.25 mole calcium nitrate. Okay, CaNO3 2. And we're going to follow the same pattern that we just did. You're going to notice the more you do this, the more of a pattern develops in how you solve these. So we have moles of calcium nitrate. So we're going to start in the middle of your flow chart. And we're going to go right or left? We're going to go right. And so what's my next step? What do I put right here? Very good. And so we have 6.02 times 10 to the 23rd. I'm not going to mess up this time. Molecules of CaNO3 2. And that's all over 1 mole. So now this allows for my mole units to cancel out. Now I have to deal with that molecule label right here. And so again, we're trying to find oxygen atoms. How many oxygen atoms are present in a single molecule of calcium nitrate? 6. Why 6? Very good. Multiply those two subscripts together. Excellent. So we have 6 oxygen atoms per 1 molecule CaNO3 2. And now looky, we have eliminated the molecule label, and we're left with oxygen atoms as our final label, and that's what we want. So again, I want you, actually, I want to see if you can do this, okay? I want you to solve for this. And remember to refer back to your given for sig figs. How many sig figs does your given have? 2. Very good. Huh?
I think I have it, but I don't.
Well, and that's why we do this practice, okay? There, what do you have?
Okay, well, the rounding is what
Okay. What,
I've got 9.0 times 10 to the 23rd. Is that right? Okay, so when I was at 3, after that, you just like disregarded.
yes. Very good. 9.0 times 10 to the 23rd. Well done. You're welcome. So now let's shift directions and look at a problem that you're going to come across. Okay, this is the emphasis that I was giving last chapter. Okay, part B. Okay, 1.50 mole of sodium carbonate. Well, we don't know the formula. We have to figure that out based off of the rules of ionic compounds. And so sodium and carbonate, CO3. What's that?
Is this B?
This is B, yes. So carbonate is CO3, sodium is Na. Before we put them together, we got to find the charges of these two. But with sodium, we should be able to look at a periodic table and determine what its charge is going to be. 1, because it's in group 1. Okay. Now CO3, again, I didn't make you memorize these. This is carbonate. It's a 2 minus. Okay. And I'm just going to say it now. Because this year is wonky, I'm probably going to let you continue using your polyatomic ion sheet. Okay. I'm not probably. I am. Yeah. You should have received it back yesterday. Okay. Okay. So now we got to do the whooping. Okay. Oops. Haven't heard that in a while. Oops. So for sodium carbonate, we get the formula of Na2CO3. You got to know the formula before you can determine how many atoms of a particular element you're going to have. Okay? So everyone get that? Na2CO3? Did you figure it out or did you just...
No, yeah.
Okay. Okay. Now we just follow again the same exact steps we just did. Write our given. 1.50 mole Na2CO3. What's next? Avogadro's number, 6.02 times 10 to the 23rd. And that is, wait, yes, no, I'm right. Okay. I can't spell molecules. Molecules. There we go. Na2CO3. That's over 1 mole. And so that allows for moles to cancel. So now we're at molecules, and we're still after oxygen. So how many atoms of oxygen in 1 molecule of Na2CO3? 3. 3 oxygen atoms for every 1 molecule Na2CO3. And that allows for the molecule label to cross out, leaving us with what we want, and that is oxygen atoms. Let's go ahead and solve for this. How many sig figs in our given? 3. You got it?
Yeah.
Okay. Not yet, but I'll come to you. Okay.
2.71 times 10 to the 24th oxygen atoms.
2.71 times 10 to the 24th oxygen atoms. Are you starting to see the pattern that's developing? Okay. Start noticing those patterns. You've got that flow chart handy. You're going to be set pretty good. All right. Yes, question.
Are we going to use an example where it doesn't start at moles?
Aha. Oh, there's examples as far as the eye can see. So yes. That, right, what?
Are we doing another example?
Not on this sample exercise, no.
I was like,
We're going to progress through the notes. In this image right here, it's just giving you a real quick example of the various states of matter and what a mole's worth of that substance would be. For instance, that balloon right there, it's got a mole's worth of oxygen in oxygen's Brinkelhoff, so it's diatomic. So that's why you have O2. That's why it's got a molar mass of 32 grams, and that's what a mole of it would look like. And here, I've shown you a mole's worth of water yesterday, and this would be a mole's worth of salt, 58 grams of salt. That has how many molecules of salt in it? If it's 1 mole, it's got 6.02 times 10 to the 23rd. Very good. That's a lot. That's a lot. I tend to skip this slide. You know why? It's just like formula weight. Is that what you said?
No, I thought you were going to say that it looks like the last one.
Oh, no. This is the same method as formula weight. Take how many of each atom are present in the formula, multiply it by the weight you see on the periodic table, and then add them up. Remember doing that in formula weight? Y'all did it on the super quiz. So, and then instead of AMU, this time it's grams per mole. So, let's convert grams to moles. Okay, so on the flow chart, where are we starting? The very beginning. Okay, and so we only got one way to go. But do we have to go the whole way, or do we stop somewhere? We stop in the middle. Okay, we stop at moles. Now, if I can find there it is. Okay, so converting grams to moles. Excuse me. This one actually does a pretty good explanation here. Okay, so we are to calculate the number of moles of glucose, which is C6H12O6, my pointer here, in 5.380 grams of C6H12O6. So we have let's say in our hands, we have 5.380 grams of glucose. We need to see how many moles of glucose do we have, okay? So what do we write first, as always? Given, which is 5.38 grams of glucose right here. And so what do we use to go from grams to moles? Rhymes with solar gas. Molar mass, yes. But you notice how molar mass is set up here. Since we need to solve for mole, that is why mole is on top and the mass is on the bottom. Because this allows for the grams to cancel, leaving us with mole. And so after we take the mass that we have and divide it by the molar mass, we then get a really small answer. We have 0.02989 moles of glucose present. So let's look at our practice one here. We have 508 grams of sodium bicarbonate. We need to figure out how many moles are in sodium bicarbonate. Okay, so what goes first? the given. And that is 508 grams sodium bicarbonate, NaHCO3. And then our next step is to multiply it by what? The molar mass. And again, mole goes on top. So what's the molar mass of sodium bicarbonate? You got to figure it out. So basically, I want you to find if you have your periodic table handy, I want you to find the molar mass of sodium bicarbonate, NaHCO3. Same way as you did formula weights. Answer in giraffe print.
Is it AU?
It's going to be, it is, but we use the label grams per mole. You still solve it the same way.
84?
I'm sorry, but that's correct. 84 grams per mole.
How did you get 84 from that?
Okay, so you've got sodium, you've got hydrogen, you've got carbon, and you've got oxygen. Okay, So-
I know I did.
and so you forget about the 3.
Yeah.
Okay, but you caught what you didn't do, so that's good. And so let's see. Oops. HCO3 just to finalize that. That allows for the grams to cancel. And so how many moles of sodium bicarbonate do we have present? Very good. 6.05 mole of NaHCO3.
Is that the answer? That's what we did.
That's the answer. Yep. You can stop. Questions on this? No? Questions? Okay. I'm going to be real honest. Probably going to push the quiz to Wednesday. Okay. Because there's just so much in this section. You never know with the short time periods and everything like that when we're going to get to work on stuff. And so, so again, we still have to do moles to grams. We still have to do number of molecules and atoms from mass. We still have to do that. So I'm actually going to pause there. Okay. Now, with that being said, on Monday, I'm not going to give you this handout today. okay, on Monday, I will do a final walkthrough of the remaining sample exercises. So please watch that. Tuesday, when you come in, is when I will give you the worksheet to work on in class. Okay, and then we'll also touch base with it, go over, answer any questions you might have before Wednesday's quiz. Okay, so I don't want to rush this, and that's why I'm bumping it. No, but keep an eye on Classroom. I'll be posting stuff. Okay, so good job today, ladies and gentlemen. Great job. And we're gonna call it a day.